Morning students, hope everyone is doing good now. So let's start with another topic of third unit, that is coding. So we have completed with the design part and we'll start with the next phase, that is coding. So not much detail is required to be done in coding, but yes, we'll be discussing few of the concepts related to it. So what is basically the goal of coding phase? It is simply to translate the design of the system into code in a given programming language. So what we do in coding, actual implementation takes place here where we build the code in the language specified by the customer as per the requirements and the design which is already built up for that. For a given design, the aim of this phase is to implement the design in the best possible manner. So what does this best possible manner mean? That means we are supposed to prepare a code that is an optimized one which suits this particular condition the best and gives you the optimum result. That means a quality software in less time and less cost, right? So this is what the basic aim of coding is. Now, we have to make our code as simple as possible. As simple as possible means easy to read, write and understand, because if you have a well written code, it reduces the testing and maintenance effort. Right? Testers have to test this code, even maintainers have to maintain this code. So if this code is a complex one, not easy to understand, right? So they require more effort, and if more effort is required, that will increase the time, and if time increases, it will increase the cost. And we know that 60% of the cost is the maintenance cost. So our aim is just to reduce this time, cost and effort of testing and maintenance. That totally depends upon the code, how well we write the code, right? So since the testing and maintenance cost of the software are much higher than the coding cost, the goal of coding should be to reduce the testing and maintenance effort. How it can be achieved? By making it or maintaining the simplicity of the code. So simplicity and clarity should be strived for during the coding phase. It's not that you know coding, you know many constructs, so you can use the more complex strategies that no one knows and you feel like proud making a cryptic code. No, that is not required. Make it as simple as possible. Right? Now, the topics that are covered, that is taken care of during the coding phase is the coding standards, the coding guidelines, and code review. So, what do you mean by a coding standard? The standard is something, the rules and regulations which are mandatory, right? Like syntax and semantics of a particular language. We have to strictly follow the syntax. If you don't follow it, it won't work. So, that is a standard. Well, what is a guidelines? Guidelines are the suggestions that needs to be implemented, but they are not mandatory. For example, say you're supposed to write, while you write a code, we say you just write in the comment line before the code starts the name of the program or who is the author, right? Just why? Just to make it understandable. Okay, what actually this code is for. Or you write the comment lines at the intermediate step. So that is not mandatory. If it is not there, then also the code will run properly. So they are simply the suggestions that must be implemented to make your code more understandable or readable in nature, or right. So we add these guidelines there, but they are not at all mandatory. Code review. Once the code is over, we have to carry out a review of the coding phase. So we will be doing two methods under this category. Let's see what are those. So first of all, starting with the coding standards. So good software development organization normally require their programmers to adhere to some well-defined and standard style of coding called as coding standards. Adhere means we have to follow it strictly. Those well-defined and standard style, I said syntax and semantic, or call them as rules and regulations. A code a coding standard gives a uniform appearance to the codes written by different engineers. Now we know that a project is a very large project and number of people work together sitting at different geographical location. So there might be hundreds of coders working on the same problem, right? So you have to use a standard terminology, that is, it must be uniform. So if you're going to follow these standards, so it won't create any problem because everyone will be using the same constructs. It enhances the code understandability. It encourages good programming practices. This is also true. A coding standard lists several rules to be followed during coding, such as the way variables are to be named. Variables to be named, I mean, is which one to start with a capital uppercase one, which one to start with the lowercase letter, which all will be represented with all uppercase. So we have different you can say the constructs. We'll see in the next slide. The way the code is to be laid out, right? Error return conventions. So there are certain rules that has to be taken care of, right? Coding standards are mandatory, remember. So let's take an example. Say we are talking about the C language as of now, right? So the first thing or the standard is rules for limiting the use of global variables. See, not every variable can be defined as a global variable. Normally, we take maximum ones as the local ones. Only one or two, whose value is not going to change, is taken as global. So you must limit the use of lesser number of variables should be defined as a global variable. Now, the content of the header preceding code for different modules. Right? Let me check. Yes. So what should be the header content? That means the comment line that we add before the header, right? So there must be some proper, you can say the syntax or the parameters that should be mentioned out there. See, the first one is the header must consist of the name of the module, date on which the module was created, author's name, right? Modification history, that means who all have modified, when the modification was made, what was the modification, everything has to be written out there. Synopsis of the module. Synopsis means brief introduction of the module. Different functions supported along with their input output parameters. Global variables accessed or modified for the module. So it's not that like in the lab file we just write the name, our name, the author's name, class, roll number, section and all, and the program name. For a proper, like you say, real world project, we must add these things there, right, in the header. Now the naming convention that we are talking about. Global variables, local variables and constant. So if you recall it, how do we write or declare a global variable? It always starts with a uppercase letter. While a local variable, that always starts with a lowercase letters. While if it is a constant, it's all the uppercase letters. So this is something which is, you can say, a construct or a syntax that is mandatory. If you don't follow it in a C language, the program will not run. It will give an error. Now, error return conventions and exception handling. Generally, what is taken up? We take two values, 0 and 1. 0 for one condition and 1 for another condition. So this should be specified. Now what are coding guidelines? Coding guidelines are the suggestions, I say, that must be taken care of during the coding. They are not mandatory. Now few of the guidelines, say in C language we are talking about, do not use a coding style that is too clever or too difficult to understand. Make your code as simple as possible, because a code can be prepared in number of ways. For the same problem statement, you can develop it using a simple construct, you can use it using functions, you can make it using pointers, you can make it using structures. So our aim is just make it the simplest one, not the clever one or the complex one. Avoid obscure side effects. So what are the side effects of a program? We must write the code in such a way, like say, whenever we make the functions, we use actual parameter and the ones which is present in the definition, right? So it might happen they must be like we use a different name for that, and they must be in sync with each other, right? But sometimes it happens once you're calling a function, it changes the parameters present in the definition part. So that is something known as side effect. It must not be there. So you have to take care of this while coding. Do not use an identifier for multiple purpose. Like generally what we do, we take a temp, right? And temp we use, say for addition, we took say temp, and then we said it's equal to a plus b. It uses over. Now division, again we use the temp variable. We say perform say subtraction, it's a minus b, temp equals to a minus b. That means temp is being used at multiple locations. We must avoid it because it might give error finally. The code should be well documented. Well documented means comments will be added wherever required. You must add the comments, right? The length, okay. Well document में we do have an optimum range also. For example, are we supposed to add the comment line after each line in the code? No. If you're going to add the comment in each line, it is going to increase the size of the code. And size is directly proportional to the effort. So if the size increases, effort required will be more. If effort increases, time will increase. Time increase, that means cost will increase. So beyond a certain limit, you cannot increase the size also, right? It has certain restriction. So it is said that the optimum number is after each 3 source lines, a comment line must be added. Again, after 3 source lines, a comment line must be added, not after each line, right? Then the length of any function should not exceed 10 source lines. Now we make the functions, we write the definition, but we never take care of the number of source lines. We normally write the function of even 20, 30, 40 lines also, right? We never take care of the optimized code, never we take care of the source line part. Here it is said that whenever you're making functions are made just to make your things simple, right? You can reuse at different locations. You don't have to write it again and again. So it must be small in size. So the size optimum number is, it must not exceed 10 source of line. But if it exceeds, it hardly matters. It does not have any impact on the code, right? It is just a suggestion only. Now, do not use go-to statement. This is known to everyone. Again, if you use it, again there will be no errors. So these are the few of the coding guidelines. Now, what is a code review? Once your code is successfully compiled and you have identified all the errors and eliminated it, right? So that is what we are talking about, individual code. Now, what is code review is for? The code review are extremely cost-effective strategy for reduction in coding errors and to produce high quality code. We are supposed to improve the code, right? And we are trying to prevent the errors actually in the code, right? Normally, two methods are being used as a code review. One is known as code inspection and second one is known as code review. Code walkthrough. So what is a code walkthrough? As the name suggests, code walkthrough is, simply compare it, walkthrough. We are walking through the code. Okay, that is one by one. You are supposed to check each and every statement which is an error, right? So it's not we'll be doing it with any tool. This is an informal code analysis technique where we are going to hand simulate the code. That means we are going to trace the code one by one and we check for all the errors or the loops, whether it is working logically, it is being correct or not. For example, so you are supposed to print a pattern like we prepare or print a triangle with asterisk printed, right? So what we do basically, we write roughly we write a for loop having two variables I and j, and we identify the condition for I and j and we try to implement. We check if I is 1, then we take the j values from say 1 2 3 4 5. For each I1 j1, I1 j2, I1 j3, right? We check what is the output which is coming after it. Then the second loop starts, right? So I changes to 2, again j will be from 1 to 5. So this is known as hand simulation of the code, not with the code tool. Sorry, you have to check one by one each line and check whether the loop conditions are being correct or not. So this is what is informal code analysis technique. So we are going to walk through the code and check for the errors. Now, which type of errors are being identified? We discover the algorithmic and logical errors in the code. We are not talking about syntax and semantic errors, right? We are only checking whether the algorithm you took is correct and logically the loops which are being taken, they are also not in error. It gives you the desired outcome. So how it is performed basically? So code walkthrough is a process in which, say, a code walkthrough meeting is scheduled next week. So prior to that, say 3 or 4 days prior to that, or few days before that, the code is given to all the members who are supposed to perform this code walkthrough. So what they do is they are being given the code to hand simulate it and identify the error whatever they feel like. So they check the code, read and understand it properly, identify the applying multiple test cases, and then identifying their outcome. They get certain outcomes. So each member, say 5 members, let's assume, they hand simulated the code prior to the actual meeting which is to be conducted next week. Now whatever their findings are there, they gather together the day of the meeting and they discuss their findings. So they got the time to properly evaluate the code, check it properly each line by line to check for the error. And once they collect together, they are thorough with the code, they have a proper understanding and they have the results also. So this is what the method is, right? So each member selects some test cases and simulates execution of the code by hand, that is trace execution through each statement and function execution to identify the algorithmic and logical errors. Now findings to discuss these in a walkthrough meeting when the coder of the module is also present. So the you can see the code was given to the other development team members. Coder himself have written it and he has tested it. Now we are asking other team members or the development team members to identify these type of errors, because if coder is being asked to identify the error, we always feel we have written the code, it will be correct only. Definitely we overlook certain things, right, due to overconfidence. So this is what the findings are being identified by other development team members. There are few of the guidelines to carry out the code walkthrough meeting. The team performing the code walkthrough must be an optimum number, that is 3 to 7 only, not less, because they won't be able to identify more errors. If more, there will be more chaos. So optimum number is 3 to 7. Now, the discussion is focused on discovery of error. We just have to identify the error, not their remedial actions has to be identified. Only identify if the error is present or not, or which all type of errors are there. Managers do not attend the walkthrough meeting. So managers, that means you can say the team leaders or the project manager, right, who they are not allowed to attend this meeting, because if they are allowed, the other team members won't speak. They will hesitate to give their findings because they feel they will be evaluated based on that. So to avoid those kind of feelings, we say managers are restricted. They are not allowed to attend this meeting, because our aim is just to identify the errors that should be carried out properly. The last technique is your code inspection. Code inspection is simply inspecting the code, that is line by line you are going to inspect each and every statement to identify the commonly created errors which are created due to oversight and improper programming. So we are simply talking about the syntax and the semantic errors here. Code inspection is for syntax and semantic errors, the commonly created errors, right? Good software development companies. Now, what is required here is, if I give you a code and I ask you to identify the errors manually, right? So it might happen I skip one or the other error. This is possibly true, right? Because each time even you execute a code on a environment, any environment turbos your code blocks, you find new errors are being created. So if manually we are doing it, definitely we are humans, we will be overlooking some errors, right? So what is done is, each and every company has a list of commonly created errors, right? All the errors they identified while working on different projects, they keep on adding it. So stats, they collect the statistics. That means they have a company disaster list actually, where all the errors which are being created previously and commonly created errors are being listed there. So how does this list help us? Say this is the list, commonly created errors, it is being listed down. So what you'll do, you'll take the code and you'll compare whether this first error is present in the code, then whether the second type of error is present or not, whether the third type. So there is a least possibility that we skip one or the other error, right? So now what are the commonly created errors? We call them as classical programming errors also. It may be the use of uninitialized variable, right? Jump into loops, non-terminating loops, incompatible assignments, array indices out of bound, improper storage allocation and deallocation, mismatches between actual and formal parameters, like in the I've given one example, they are known as actual and formal parameters in the functions, use of incorrect logical operators or incorrect precedence among operators, improper modification of loop variables, comparison of equally of floating point variables, etc. So these are few of them, they can be more. So that is being listed here and we compare whether these type of errors are being present in our code or not. So it becomes easy to identify the errors with the help of this list. So that's all for today. Thank you all.